believe what I am seeing. Absolute bullcrap. Well, howdy everybody. So, we are back at this project. I should give you a little walk around in a minute, but at any rate, we have done a darn lot of welding on this thing. At this point, between handling and flipping and flapping and welding, we've got a solid 2 days into this thing already. Just to give you a synopsis, this bore over here was blown out, and then both faces were just radically worn. We're talking like over ½ inch worth of wear. We opted to lay the thing up on its side, fill that, which I mean was literally hours of welding to put all that material back in, and then took a 6-inch 16 grit cup wheel and hand flatten it back out. I'll show you that. And then we had to weld the bore, and then the other thing that we discovered was right in here, there was a huge crack getting started on each side. Initially, I couldn't understand what was going on, and then on the inside, you can see this is actually a separate piece that was welded into here, and I don't understand why they ever did this, but that piece, first off, when I air arced it out, we discovered there was like a 1/16 of an inch gap behind it. They never had it uptight to start with, and then they ran one weld bead and ground it off flush. Just absolute garbage manufacturing. I mean, this is subjected to all kinds of loads, so what had happened is, you know, it gets pounded and beat on, and just the pounding, it basically just blew out that weld joint from impact. So we air arced out that entire seam about 1 inch deep, inch wide. I think we ended up with 6 passes of 5/32 rod in there. So at any rate, all of that, you know, on both sides, it's a lot of time. But I'll bring you guys around, show you some of what we did, and then we're going to get set up and get this thing on the boring mill. So here you can see where we've done some major, it's got a little surface rust, doesn't show up as well, but major air arcing and filling there. Has to be ground back off flush because of course this goes in between the ears on a bucket. But why they didn't V it out to start with, if they did, they were only 1 pass deep. And then here's where the real work is at. I've got a fair amount of smoke on it now because we've welded the bore up since then, but this face, no joke, was missing ½ an inch of material on each side. So just enormous amounts of weld fill up in there, and then hand with a big cup wheel, hand ground in with a straight edge coming off that face. I just did not feel like trying to deal with that on the boring mill. And the original, mind you, was not a machined surface on these. They literally just welded the plates up. So it's like, all right, if it ends up flat and square to the plate, you're back to what it originally was. So there is, no joke, probably 1.5 hours or better of just grinding on each of those faces, because what you end up doing is weld it up as best you can, grinding, finding the low spots, filling them in, grinding, and you've got to start grinding. Those your straight edges come from here. You got to start grinding your way across from this edge, checking and filling as you go. Just to get those both filled and ground, I believe there was, at that point, something pushing 12 hours into this thing. But we're getting over the hump now. It's just time to get down the boring mill. So I'll get you guys set up. And I think what I'm going to do, I don't happen to have any 3/16 key stock or 13/16 key stock, but I've got these table keys that I made for squaring stuff up. The spacing doesn't work out to allow me to have 2 blocks with keys in it, but I'm going to put a key in one of them, slide it in this back T slot here, and then I'll put the other V block up as far to the front as I can, and then we're going to set it down. Now, I'm not altogether convinced that that's going to get it perfectly square, but it should at least get me close. And if for some reason it proves to be way out of whack, then we'll figure something else out. This particular coupler weighs 1,960 pounds, by the way. So she's a serious fistful. Okay. So the issue here is that I have to be able to get all the way through this hole unobstructed. I think what we're going to have to do is go up a bit more. and stand a block. I'm basically wanting to get a 3-point type of system going on here is my objective. I haven't even figured out how I'm going to clamp this thing down yet. Right now I'm just trying to get it setting. So if I get 2 tie bars through there, and then probably slam an angle plate up against it here just so that I can't push it, you know, that's what's most commonly happens. If you're cutting and you all of a sudden blow your tool pit and you're under power feed, it can generate some huge forces and vibration all at the same time, and that's when you'll all of a sudden and you'll start walking that thing. So most of the time when I'm boring, I try to get at least 2 3/4-inch rods through. I like 3 or 4, but in this instance we're not going to get it. But the biggest thing is I always try to get something slammed up against it so it can't push it. So I think that'll work. Let's start getting this thing rigged. Y'all are starting to get a first-hand taste here of why it is that it's not possible to have too much blocking and tooling for setting up on the boring mill. Okay, that's starting to look doable. I need to scoop forward a little bit more, and then I think I can get dropped through there. I'm still looking good here. Tell you what I think I'm going to do is I'm going to, on the other side actually, run up and down this outside plate for the dial indicator, and I'm going to square it up, and then I'm going to come over here, because that's a longer, I wish I knew the terminology better, but if I just come up here and measure off the edge of my 2 V blocks like I originally said, they're only, you know, outside to outside about that far apart. So because this distance is longer than that distance, I'll be magnifying inaccuracies. Now, if this side plate, we don't know that, but assuming it was pretty square to these bores to start with, if I square up to it and then measure this, if that's halfway square, then the measurement here will look fine, even if it was, say, a little bit off, because I'm not using the right words, but you get the point. I want to see if I can square up off the side plate first, and double check it by seeing if my blocks are square to the end of the table or not. So yeah, the face of this thing isn't even close to being square to the pin is what I'm discovering. So we're going to have to loosen it back up and shift it and get this dimension right. We can't trust the side at all is what we just found out. Well, you know what? It's good enough. This stuff is never manufactured as common as I would build it to if I made it. This is where this can get kind of scary, is we've already verified that this thing is, that the basic body of this thing is way out of square to its pin bores. Now what we don't know is how good of a job did they do of having these 2 bores and really square to each other, because if they're very far out, I can start having trouble with running out of my weld. About to find out. few spots that aren't going to clean up, like that one. These would probably all clean up. That one probably not, and that one probably not. So we're going to go in here and do a little welding. I've got a good 20 thousandths to go per side yet, so this is a good time to stop and touch stuff up. Alright, so we've been in there with that boring head, trying it, but it's just, we're stretched out too far. 3-inch spindle, reaching across, I didn't even measure how far, but 24 inches or something, it's just too chattery. I can take, at best, about a 10 thou on a side cut, and I've got close to 100 thou on a side to take out of this hole. So we're not doing that. I'm going to set up a boring bar and an outboard bearing, and then we're going to go back at it. Alright, let the fun begin. Substantially healthier than last setup. That was a bunch of progress. Now the question is, yeah, we got some ugly looking spots in that bore. She ain't cleaning up. We'll cut some more. Touch up doing this one. First pass after the weld up. Alright, well, we are as done as we're going to get on the boring mill. I fought round after round of flux inclusions in here. I had somebody helping me, and I think the moral of the story is I need to weld my own bores. The face welding part, that's great, that's fine, it's all, you know, flat, but in the bore, it's so easy with that dual shield to get one bead flowing over the other, not get all the way in, and I don't know what it was. That one wasn't too bad. This one, I lost count. I probably ran into little flux inclusions and had to pull out of there half a dozen times to fix spots in the bore. So, at any rate, it really turned this one into a pain in the butt. So anyway, I'm ready to call it a night, get the heck out of here, and we'll come back and wrap this up in the morning. So catch y'all guys later. I'll probably shoot some video of wrapping it up in the morning. Alright, it's still 10 o'clock at night, well, a little later than that. I decided I need to just get this thing done. I have no idea when they're going to try and come for it in the morning. And honestly, I decided it just needs to be finished. So, here we are. A little bit on the snug side. Not sure actually if it's that it's too snug or if there's some slight misalignment, which is entirely possible. You know, you get a boring bar set up like that. When you're setting the bearing up, you can have a little bit of deflection one way or the other. Anyway, I think we'll do a little bit of buffing in that hole and see what she does then. I discovered that the two pins are 5/1000ths difference in size. They're supposed to be the same size. I mean, they're both 110 millimeters, but anyways, and of course, I grabbed one, measured it, bored this to fit the one that I grabbed. I had one of them, as you recall, in there getting set up on the V-blocks, so I fit it to the other one. Well, I happened to fit it to the smaller of the two, and the bigger of the two, it turns out, is the one that needs to go in this hole. So 5/1000ths is like up, might as well be the Grand Canyon size-wise in this world. So anyhow, I am honing this out with the Sun and Hone to accept the other pin. I think I'm going to go get my micrometers, and I want to measure up and down that pin. I'm suspicious that it ain't even round. Good grief. Stinking pin is 2/1000ths out of round. I thought that's what I was feeling when I was trying to stick it in there. It's 2/1000ths fatter on the side that's got the true hole than it is the other way. What a load of crap. Garbage, garbage pin. Good freaking grief. So it's, here I'm measuring 4.33, 4.28. I've got 2/1000ths just between there and there. What a piece of crap. Oh, I don't know what to do with this, because what I'm seeing here is if I flip it around and try and stick it in the other end, or if I do stick it in from the other end, it'll go, oh, that's nice. The ends are way freaking bigger. Both ends are. Yeah, it's almost 3/1000ths bigger on the ends than it is in the middle. It's just bonkers. I've never seen a pin that bad. Now I'm curious about this one. As anticipated, way smaller. So this one is at least actually round. This one, I think some guy wearing flip-flops in Bangladesh carved this thing out on some ratty old lathe and then hand sanded it to finished dimension. It isn't round, it isn't straight, it's shaped like an hourglass and is out of round by 2/1000ths in some areas. See, the reason they're getting away with this is if you stick this in a hole on a used machine that's got thumped around a bit, it's got 10 thou slop in it, goes in there and rattles around. You stick this in one that I've just done a nice job of making round. See, the problem here is I've got to decide where the compromise is going to happen. In all honesty, I'd like to stick this friggin' thing in the lathe between centers and OD grind it, but the customer's not going to want to pay for my time to do that. I'm going to be honing here for the next dadgum month is what this means. Like, the ends are the biggest and they're the worst out of round, so I'm going to have to, honing, take it out until it fits the largest dimension. If I had a nice selective way of taking part of this down, like I was just trying to think, I've got like an import knockoff of a Dynafile. I might actually take that to some of the wider sections in this darn pin and see what I can do to it. Alright, well, I gotta do a little head scratching. I think I'm gonna take, this part out here where the hole is sticks on through, it's not making contact. I think I'm gonna take a flat wheel and a grinder and buff the end of this thing down, see if it doesn't make contact. Like, that's the biggest spot in the whole pin, and there's no point in me making the hole clear what is going to be the biggest section in it and then doesn't even touch. So I am thoroughly disgusted with this pin. I'm going to be asking them where they got these, because this is someplace I will never buy a pin from again. Alright, so this starts to tell the tale. Look at this. So I'm on their center, nice factory center. This chuck ain't dead on, but it's pretty accurate. And this far from the chuck, it's having almost no impact. The center's doing everything. Look at this. Skimming pretty good here. You see just what I was measuring. I'm not hitting it all inside. That's the reason that I'm measuring much narrower here than I am here. And then you can see like big fat band right at the end, right where you don't want it. Worthless turd. I think we're going to just take a skim cut all the way down this gadgum thing. It's not hard either, notice that? Crazy soft. But anyway, we'll go back at it here. Just look at this. I cannot believe what I am seeing here. I mean, look at this. We're like, it's all over the map. Big heavy fat spot. There's still nothing in here. Absolute bull crap. And then I'm curious over here. We're definitely trying to polish a turd here. I think what we're going to do is cut my way to the center and then flip this thing around and get from the other way. The middle makes no contact. It's out here at the ends that we really care about. So if there's going to be a funny ripple, I'd rather have it do it in the middle. Interesting. So that acts hard. So the only part of the pin that's hard is the end. Dead soft in the middle and hard out on the ends where it doesn't matter. Right, let's see, out on the ends. Out here where the pinhole is. See that? No more fire. Ridiculous. Yeah, hardest part of the whole pin is out here where it doesn't touch anything. Total BS. Alright, we won. I forgot to video it, but I ended up, after I brought it back from the lathe, it slid through this side. I had to do a little bit more honing here, and then I just did some buffing because I had some ripples and dipples in it and buffed it up a little bit with a flap wheel. But anyway, as you can see, it now slides in there. I have just here the tiniest tunk, probably 2 thou clearance or something if I had to guess. But anyway, this one is done. They're going to come pick it up today, and it is not my problem anymore. So catch you guys in the next video, but be warned, don't buy Pakistani pins.